I'll start this lesson by introducing you to the idea of agents. You will learn how agents use tools to accomplish their tasks, and at the end, I'll share an overview of the Agentic RAG, which is an advanced framework for building RAG-based solutions. A typical application consists of an input tier, a mid tier, and a backend tier. Input tier provides an interface through which the application allows external entities to interact with it. These interactions may be initiated by a human, for example, via a user interface on phone application, or an application input, for example, web API, or a machine such as an IoT sensor. The mid-tier consists mainly of the orchestration logic to process the received input. This tier is responsible for interpreting the input so that the received data can be consumed by the application logic. The processing logic is built by the programmers using typical constructs such as if then else, loops, etc. The logic implements the interactions with the backend. The backend of the application primarily consists of data stores, for example, relational databases, NoSQL databases, etc. In addition, this layer exposes interfaces that are external to the application. Application uses these interfaces for interacting with its environment. These may be thought of as APIs exposed by other applications, systems, or even sensors. Let's double-click on the orchestration tier. The orchestration layer, or the mid-tier, is static in nature. It is built by the application developer based on the application or the task requirements. Developer plans the orchestration logic and then implements the plan in the form of static code. This application code can interact with its environment via the interfaces exposed by the backend systems or applications. The idea behind the agent is that the static code for the orchestration can be replaced by an agent that at runtime plans the logic and utilizes the backend for fulfilling the application task. Think of an agent as a software component that uses LLM as its brain. Let's dive deeper into this idea. An agent is a system that uses an LLM to understand the task. It creates a plan, it executes the plan, it uses the information received from the backend for generating the output, and optionally, it can take actions. Example of actions are an agent can send an email. A highly sophisticated agent can even purchase stocks on behalf of the user. More on this later. The external interfaces exposed by the backend are presented to the agent via a construct that is referred to as tools. Think of tools as wrappers for the backend APIs or functions. An agent uses these tools to interact with its environment. Tools is what makes it possible for LLM to use dynamic context. For example, we can provide the city weather information as context. We can provide the current stock price as context. Tools contain metadata for the external interfaces. This metadata is what the LLM uses for understanding the tool's use. Some tools can take only a single string as input. These tools are referred to as unstructured tools. Other tools may take multiple input parameters. Such tools are referred to as structured tools. A collection of related tools is referred to as a toolkit. For example, a file system toolkit consists of multiple tools such as a tool for reading a file, a tool for writing a file, a tool for deleting a file. A single-step agent involves completing a task or query by generating a plan and then executing it to generate the output. Both planning and generation are carried out in a single call to the agent. Agent setup requires access to an LLM and one or more tools. When an agent is invoked, it uses an LLM to create a plan. The plan consists of execution of one or more tools. Agent executes the tools as per the plan. It consolidates the responses from the tools. It then passes the responses from the tool along with the plan to the LLM. This second call to the LLM is for the generation of the output. LLM uses the responses as context to generate the output. Agent adjusts the LLM's output and sends it to the caller. Let's take a look at an example of a single-step agent. Let's say the user asks an agent-based application, I live in New York City, should I carry an umbrella today? The agent will use the LLM to generate a plan which may look like this. Get the weather information for New York City using the weather API tool, and then use the response from the tool to check if it would rain today or not. And if it would rain, then the response should be yes, you should carry the umbrella. Agent executes the tool suggested by the LLM to get the weather information. Let's say the weather prediction is 80% chance of rain in New York City. The agent consolidates this response information, the plan, and the question and send it to the LLM for the generation of the response. The LLM generates the response. Yes, you should carry umbrella as there is 80% chance of rain in NYC. If you consider it, this flow is somewhat similar to traditional retrieval augmented generation pipeline. Like a RAG pipeline, it retrieves context from an external source, but that's where the similarity ends. In this pipeline, decisions are made about where to retrieve the data from and how to use it for generating a response. This type of RAG pipeline, which incorporates agents for enhanced decision making and interaction, is referred to as Agentic RAG. Let me provide you a more detailed definition of Agentic RAG. Agentic RAG is an advanced framework that enhances traditional RAG by integrating agent-like capabilities, allowing the system to autonomously retrieve, reason, and generate responses with improved accuracy and relevance. In this lesson, I introduce you to agents, tools, and Agentic RAG. Agents are software components that use LLM for planning and decision making. Agents interact with their environment using tools. Tools may be thought of as wrappers for APIs and functions. A single-step agent creates a single plan and then executes it using tools. It then uses an LLM to consume the responses from the tool to generate the output. Now, if you're wondering if there is a multiple step agent also, the answer is yes. You will learn about it in later lessons. In the next lesson, you will try out a single step agent. Happy learning, and I'll see you in the next video.